Hi, we are Team Boreas. Our project is the wind car drivetrain and control. The motivation of the project was to continue research on a wind-powered vehicle suitable to compete in the Aeolus race. Last year, a group of EME students demonstrated the concept of a wind-powered car. This year's project was split between upgrading the third-scale wind car and research into the full-scale technology and design.
A number of improvements were made to the third-scale model. Maximum power point tracking is carried out by the vehicle's control system. This ensures that the turbine is always operating close to its optimum tip-speed ratio and therefore providing maximum power to the motors for any given wind speed. Energy storage was implemented in the third-scale model using supercapacitors. The Aeolus race permits a 30-metre push start before the timed section of the race begins. The supercapacitors have been installed in such a manner that they can be charged by both the turbine and the motors, which have been configured to act as generators during this period. This ensures a significant amount of energy has been captured which can be utilised throughout the duration of the race.
Bluetooth communication was utilised in order to send control signals to the vehicle and display up-to-date measurements via a graphical user interface. The control signals enabled operations such as applying the blade brake, wheel brake, and overriding the maximum power point tracking.
As part of the investigation of feasible technologies, a MATLAB model was created of the vehicle drivetrain using the Sim Driveline toolbox. The model included motor and transmission circuits as well as the vehicle body. A script was created to run simulations and enable model parameters to be easily changed. Graphs are also generated to determine motor current, speed and torque values during the simulations.
The chassis was designed using Excel and Inventor 2014. This allowed the chassis to be easily iterated and tested. The chassis was designed to meet the specifications given in the Aeolus race rules.
The project research conducted over the last 2 years will be compiled into a methodology. This methodology will give a step-by-step detailed guide to how to build a full-scale wind-powered vehicle.
The conclusions drawn from this project will be used in order to aid Strathclyde's development of a full-scale wind car which can be entered into the Aeolus race in the future.